Hi everyone, this is Team Blue Drones and this is the screencast for the third milestone of our DevOps project. In this milestone, we had to automate the deployment part after our project succeeds through a build, test, and analysis phase. And then we had to have some feature flags and a canary version of our app. So I'll start off with showing you how to deploy it first. So right now, as you can see, my DigitalOcean control panel says that I have no instances there. So it's empty. So now I'll start off with making some changes so that I can make a commit. So as soon as I make a commit, it will basically push uh, everything online, do the build test analysis phase, and if the commit is successful, if the build test analysis phase is successful, it will deploy it. So as you can see, there's a small deploy flag. It basically means that it has been pushed to deployment. So if I refresh my DigitalOcean control panel now, it should have, yeah, it has one instance starting up. So it's gonna take some time because it's gonna start up three different instances, wait for them to basically start up properly, boot up, and get ready to be to work, and then it's gonna use Ansible to deploy everything. So I'm going to pause this demo right now. I'm going to resume this as soon as it's done because it's gonna take around 5 to 10 minutes to do this. So um, I can show you now what basically happened. So first of all, these droplets were created. So I can further show you the Ansible log. So once they are created, we use Ansible to do the configuration management and deploy our apps on the servers. So we had a Redis, we had a Redis server, we had a proxy server, and then we had an app server. So we had a total of three components. Now, so basically, the second component is a proxy. So I'll copy the IP from there and we'll make it run. So okay, so it goes to the other server, which is the app server. So the proxy redirects to the app server. So this is the way our basic um, system works. Now I can show you how to basically generate alerts because they have a monitoring script that's on the server, but in order to make it work, we'll need to SS it in and generate some stress on the server. So, so I got into the server. So now, first of all, I have to generate some stress. So I'm using a stress library for that. And run it as a background process. So once that starts, I can run my monitor script. So monitor basically monitors on the basis of CPU usage and memory usage. And when it exceeds a particular threshold, it not only sets an alarm by sending an email, but it also scales up and creates a new instance. So once I run monitor, so that says message sent. So what basically happened was that was a reply from the server which did that. So it says hi CPU load, and okay, now I can just kill this stress module. So CPU load does not stay that high and does not affect my system. And basically this was created. So this one is uh, basically the new instance that's created, and that's basically the scale up that happens. So again, it will take some time to get deployed because it has a lot of stuff to go through. First, it needs to get working, and then Ansible will basically install a bunch of stuff on it, which takes a lot of time. So I'm again going to pause it and resume once the installation part is done. So there was a small bug, not exactly a bug. I don't know why that it happens, but it happens with few times. So you can see that the IP is changed because I had to basically run the scale function again, because when I ran the scale function for the previous time, it basically did not install the JQ model for some reason, and it keeps on baking on random models. Sometimes it bakes on JQ, sometimes it bakes on Git, and it's basically it resets its connection with the digital server instance for some reason, DigitalOcean instance for some reason. So I don't know if there's something wrong with the DigitalOcean API or something, but sometimes it randomly breaks. So anyways, I basically pinged the same API which my monitor script was pinging, and it generated a new scaled up instance, which is this one. So basically now when I so this one was my proxy. So now when I ping this, so it first takes me to the older instance, and it should basically take me to the newer instance as well. Yeah, so there's the 138 one, the new instance that it takes me to. So this is how the scale up works, and the new instance is basically in the Redis queue. So this is basically about the scale up. So another feature that we had to implement was feature flags. So for feature flags, what we basically do is we go to this URL and we say feature, and we give this the API, the IP of the Redis server, which is this one, and this will basically turn on the feature flags. So I can show you now what happens. So um, go back and copy the IP from my proxy, and there it is. So it basically prints out the IP of the server. Yeah. So that's our feature flag. And once we ping it again, it's gonna basically turn it off. And if we again go there, there'll be no feature flag. So we can keep on toggling between that. It's fun to do. So that's the feature flag that we had. So apart from these things, the next thing we had was basically a canary uh, instance. So for that, we need to first check out the developer branch. Now again, I'm gonna go in and add something new to commit. So now it pushes everything onto the develop branch, and on the develop branch, basically, when it runs through the build pipeline, um, it goes through the exact same thing that the code on the master branch goes through, and then it's again now it says deploy. So with the develop branch, it's not exactly the same as the master branch. So in case of the develop branch, the deployment is basically of the only one instance, that's the canary instance. So once the canary instance is deployed, it adds itself to the Redis in the form of a key value known as canary URL, and it sets the canary flag on so that the proxy knows where to redirect to. So I'm again going to pause it, and as soon as my instance boots up, uh, I'm going to resume the that took a while, but basically it got deployed. So it actually gave a failure at the end, but it was a connection timeout to the server. So um, for the Redis part, so that was a small part. But anyways, so once the canary is deployed, the traffic should be properly routed to the canary server. So I'm gonna copy this, paste this here. So basically, it gets first it got directed to a normal server. So just to distinguish, for the canary, the IP is 104.236. Another normal server. Now it gets to the canary server. So basically, one out of every 4 requests go to the canary server. And if I start this again, go back to the normal server, and so on. So this is the way the canary server works. Now I need to also show that once an alert is raised on a canary, then it goes down. So for that, helps me to basically SSH into the Canary and start a stress generator, which basically generates enough load. So let me just go in. Okay, so now I'm here. Let's do a stress uh, and -C very in the background. Okay, so there's a stress being generated. So now the monitor script is run basically kill the canaries. It says canary kill, and to show that canary is actually killed, what I'll need to do is show you that when reusing the proxy, it doesn't go to the canary. So right, it went here, went here. Oops, it's actually no, it's not going to canary. It's going to 72, and this is this one and 88 only. It's not going to 61, which is the canary server. So the canary server has been, so this is the 61 bit canary server. The canary server has been killed successfully, and by the race alert, and it's the canary server. So I think that covers it all, and that covers all the different portions of the milestone. So to sum it up, I basically had my build server on AWS. So this is my build server, and this build server did everything from spawning new nodes to deploying to everything. So it had different APIs constructed, and using those APIs, I did everything. So that gave me a lot of flexibility, and basically I use DigitalOcean. So DigitalOcean isn't that great because it's pretty slow. That's one thing, and sometimes it fails or the instance crashes or something randomly, and something that doesn't get installed, and you have to boot it up again. So that's a bit problematic about DigitalOcean, but overall it's pretty good. It's better than AWS because AWS took around 30 minutes just to create 3 instances at first. Um, Also, the scale up was done using the same Ansible script as for the initial deployment, but it just deployed one instance instead of multiple. And every instance added its own IP into the Redis server, and it had just the information on the Redis server. So that made it possible to easily scale up. So I think that's about it. And thank you for watching.